All right, next up, we're going to look at the roof assembly. Again, this one's going to kind of blast right by because you've already seen it, and there might already be an assembly for it, right? So this is a wood frame structure. The roof assembly is going to be made out of joists and plywood, just like the floor. In fact, when you're looking at like fire rating details and stuff like that, they treat floors and roofs almost exactly the same because they have a lot of the same, physical and fire resistant properties. So this particular roof, we're going to modify to have, that's a rafter. Let's take a look at what the roof, wood rafter 8-inch with asphalt shingles and insulated is. So we'll click that. All right. I want to put that on fine real quick. Yeah, it should be fine. Okay. So what's that? Wood rafter, 8-inch asphalt shingle insulated. Okay, that's just the one that's there out of the box. We're going to investigate it and see if it's what we want. Oh, whoops. Because it looks pretty close. So go to Edit Type and open up your structure settings. And let's see if it fits. We've got the structure itself, which is a wood joist, and the plywood, and then asphalt shingles. Okay, that's a very, very simple roof structure for us. Okay. One thing I do want to do, because I notice that the material itself, when I hit OK and change the material, didn't really have any patterns or anything. I just want to see if there's anything programmed on it real quick. So let's take a look. There are no surface patterns. I don't know if I have any shingle patterns on here. So I'm just going to quickly take a look. Let's block. Well, yeah, we could do a shake shingle. All right, I hate shake shingle, but we'll use it for now because you can see patterns. So do me a favor and go into the asphalt shingle setting, material settings, go to surface pattern, go over to model patterns, and scroll down to shake. Hit OK, hit OK, hit OK, and hit OK. Okay, so it looks like that. It's a shake shingle roof.
Shake 6 inches?
Huh?
Does it shake 6 inches?
Yeah. Okay. Hang on. All right, so guys, can you all pause modeling for a second? I just want to show you. I want to show you just kind of how this sort of element behaves because there's not much to modify here in this lesson. But let's take. I'm going to show you a section and how that's going to relate to the actual built element later. So let me cut a section across the building. I'm going to go to View. So our building now looks like this. This is the roof that we built. I'm going to switch the detail level to Fine. And so here's what you're looking at as our exterior wall and roof eave structure. Okay, so the part that I want you to understand about how these elements react in Revit is that it's not the end-all be-all perfect modeled condition. Okay, we have to utilize level of detail throughout our various views in order to get to that final result. Okay, so like the final construction documents that shows framing and everything like that. So just like we were talking about when we were offline a second ago, this particular joist element is actually going to be framed out sort of a little differently. You're going to wind up having a detail component like this. We probably need to switch that to a 2x8. Let me just quickly make a 2x8. Okay. So you're going to have double top plates like this, and then that's going to get framed sort of going down the wall down to the base. That's going to be your sill plate. And then, those elements are actually just going to be drawn onto your wall section. Okay, that's a very key thing for us to get used to now. So The other question that showed up earlier today was what happens with insulation. Okay, so insulation is not something that we embed into these assemblies. You can for certain assemblies, but for your typical like bat insulation in walls, you're going to use the insulation detail element right there. So that element, you just click it, and you guys don't have to do this right now. I just want to show you it, but 7.5 inches, and then you draw it up the wall that you're working with. Okay, so this is probably going to have like a little end plate like that, something like that, and then we're going to have like insulation that goes around the whole building. Okay. So why am I showing you this now? Okay, I just want you to understand what these assemblies are doing in the overall BIM environment, and then where we're going to go as we progress through our different floor plans and stuff, or different plans and views and sections and all that. Okay, so I guess I'm gonna probably stop with this project here and get us sort of prepared for what we're gonna do in the I guess for Thursday's class, but I just want to kind of see if you guys have any general questions about the BIM environment before I stop this exercise, because maybe there are some other key elements and questions I can answer for you right now. No? You feel like you got a pretty good picture?
Yeah. So, could you just model, is there such a thing as parts already modeled out where you can just sit them in, like a wall already modeled out with insulation in there, you throw in a window, it adapts to the window? Or am I just going too far?
Well, I mean, just like doors, windows are the same. Is that what you're saying?
No, I mean, so you're literally having to place in all these different elements into the wall, like the plates, the insulation.
Uh-huh.
Is there a wall that's already assembled? Does it already have all these elements in it, or do we have to still make the wall?
I guess the answer to that is yes. You do have to still make all of your wall types, but like I said before, like you get into an office somewhere and they've already got them all made pretty much. Generally, I don't know what kind of work you do, but like if you're just working on Type 2B commercial structures, you've got all of your CMU backup walls and concrete with metal deck floors, assemblies, all pre-built for the most part. So all you might have to do is just kind of adjust one a little bit and make a duplicate. So that's the general position of most, I guess, templates, I should say. Does that make sense?
Yeah.
Okay. But also, like when it comes to components and stuff, if you're talking about like things in the space, guys, you probably are interested in this. Some of the things that you can place in the space, like desks and stuff like that, they're already pre-made. So, I mean, you basically just grab a desk and you can put it in the space. And what I want to show you, I guess I'll show you in the next segment, but like you can just build these elements and kind of move them around in 3D and stuff. And they're all parametric. You can adjust the width, height, everything like that. So we're going to build some custom ones ourselves. Okay? Yes?
I was going to ask, couldn't you, on his question, couldn't you add like the insulation in the family editor if you wanted to create a custom wall? Or like, do you know if that would be possible?
Well, because
Or maybe other elements,
so
maybe not just insulation.
insulation is coincident with the stud layer. So I guess the real question about where you model insulation would be what do you need to model it for, right? And one of the things that the BIM environment can do is quantity takeoff. So you can basically calculate how many square feet of wood studs are in your project. And then like you can contractors will actually take your BIM model, they'll modify it, because they don't do it the same way we do, but they'll just do a quantity takeoff and build a schedule of all your walls. And so the key for that is, rather than modeling the insulation itself, can you get the same information a different way? For instance, taking all of your exterior wall types and just calculating the square footage of that core. Does that make sense?
Yeah. So I guess insulation, insulation specifically, I mean, you only really need to look at it in like a section.
Kind of, yeah. I mean, there's not really a purpose to modeling the insulation here in this assembly, but there are assemblies where you do. And let me see if I can pull one up real quick. Exterior insulation cladding. So I guess this is a, that might not be a good example. Yeah, so I don't know what that one is.
But in the family editor, you can do a custom wall type there as well.
Here's a good example. So, oh no, that's coincident too, actually. Number 2, semi-solid insulation. That one's an exterior one on battens. Sorry, what was your follow-up question?
Oh, well, I think walls are already a family, right?
Yeah, so that's an interesting, important thing to discuss, guys. It's really important to understand what types of families there are in the Revit environment. Walls, floors, roof assemblies. They're all what's called system families. You can't custom modify the parameters of system families. Okay, they're hard coded into Revit. You can only do layers. You can't create like special features for it. Those are all going to be families, not system families, that you create that interact with those system families. So like if you want to put a window in a wall, that's a family that interacts with and modifies a system family. Does that make sense?
How would it be different if you had your own custom wall family and then you added a window to it or something? Would it be any different?
No. No, it wouldn't be any different. In fact, you probably wouldn't be able to get the hosted families to interact with it the same way that you would with the Revit hard-coded system families.
What do you mean by that?
Because you won't be able to wall host. So another interesting element, when we get to families, guys, you're going to understand how these things behave. But those system families, like a wall, for instance, it's called a wall, right? And these other families that we create, like the desk and the doors and stuff that I have in here, those are families that have an orientation, right? So the desk is a floor-based family, right? When you place that in the space, it gets placed on a floor. When you place a door, it gets placed on a wall. It's a wall-hosted family. So if you created a custom wall, like your own family, that was a wall, it wouldn't be considered a wall. Yeah. Is that clear to the rest of you guys?
So it wouldn't be able to interact with the system walls.
Right. Yeah. It wouldn't wrap. It wouldn't create clean corners and stuff like that. Yeah.
Like the cabinet, you can't put it into the wall.
Uh,
It wouldn't react to the cabinet.
Yeah. I mean, there are cabinet families, and they are wall-based cabinet families, but they wouldn't react with the wall that you self-created as a regular family. Yeah. That's correct. Yeah.
Can you fix that, or is that?
Not really. I mean, you could create nested families and stuff like that, but no, not really. I mean, there's just no reason to. I don't see a reason that you would be able to create a wall that's smarter than the walls that are in there, unless it's a specialty product, in which case it would need to be a family, not a system family. Yes?
What about like a custom staircase? In that instance, would you try doing it as like a component?
Oh, yeah. Yeah. Staircases.
Or like
Right.
a spiral staircase or something?
Yeah, well, I mean, it does some simple. Revit does some stairs, like, okay. Stairs are the worst part of Revit. They for some reason haven't been able to figure out how to make it intuitive or easy to work with by any measure of the word easy. So Yeah, I would say for something like that, stairs are also a system family, but I've actually started using Grasshopper and Dynamo to model my stairs because it's a lot easier for me. What's that? Okay. Yeah, question?
Will we cross into Dynamo for stairs in this class?
No, I'm not going to teach you guys how to do stairs in Dynamo, but I will teach you some pretty cool Dynamo stuff. Speaking of which, I got a video that I want to show you guys after we take a little break. It's amazing. It is so cool. Okay, cool. Any other questions? Okay, so I'm going to give you guys a 5-minute break. We'll watch that video, which is totally awesome, and then we'll move on.